I'd like to welcome everybody to the November 17th seminar for the IMAG MSM Working Group on Multiscale Modeling and Biopandemics. As always, I need to remind you that these meetings are live streamed and recorded and made publicly available for those members who can't make it to the meeting itself. We're very pleased today to have Novadiscovery coming back for a second presentation on their work on knowledge generation software platform. As always, Tom Helikar and myself are available to take comments, suggestions, criticisms. Jim Sluka, Lorenzo, and Joel as well. We welcome comments and suggestions. We have our usual list of communication channels. In particular, we have our archive of talks. We have 150 talks. Those should probably be distributed more effectively than just sitting on a YouTube channel. So if people have ideas about better ways to communicate, the fact that we have a tremendous knowledge base, we would be very grateful. So please help us out. We have our Twitter handle, MSM Viral. You can try that hashtag, see if it helps. December 8th, we are going to have a 2-year anniversary discussion. We would very much appreciate your contributions to the IMAG MSM webpage. We're trying to build a slide deck. If you would like access to the slide deck, and we would love your help, please email Jim Sluka, jsluka@iu.edu. Anything you have on collaborations, funding, publications that have a relationship to the working group, we would like to hear about it. Suggestions, comments also. There was also a survey that was sent out to the group membership. We haven't had a very good response rate to the survey yet. Please do respond to that survey and let us know what worked and what didn't work. There are quite a few articles that have been published by coalitions coming out of the working group. There are some significant grants that have been funded. We would like to be able to present that work, maybe have you highlight the things that you think were most useful going forward. Tom, do you have anything you want to add to that at the moment?
I don't. I will post the link to the survey in the chat here in a second. I'm just digging it out right now.
Okay. Are there any other announcements for this week? Tomorrow morning, there is the Digital Twin subgroup meeting at 11 a.m. If you need an invite, we can arrange that. Adam Knapp isn't here today, but TJ is, so he can set that up if somebody needs an invite for the Digital Twin subgroup meeting and doesn't have it. Coming up next week, Thursday, is Thanksgiving in the United States. That really is a holiday in the United States, so we don't have a meeting. We have the seminar on December 1st, our anniversary presentation on the 8th. There's an opportunity for a seminar on the 15th if somebody wants to give it. As always, we really would appreciate suggestions for speakers. We are trying to build a seminar program for the spring, winter and spring. Your input would be appreciated. And I can give the link again here if you want for that suggestion form. You can also email us directly. You don't have to use the link. Okay. So I don't want to take any more time from our speakers today. As I mentioned, we have presentations of Novadiscovery. They came some time ago and gave a great talk on what they were doing. It's very exciting to see these kinds of software projects turned into companies and translational work in the area of virtual clinical trials. And so we're very much looking forward to their presentation now.
I will start the presentation with an introduction of Nova. So as you said just before, it's a second presentation of Novadiscovery. So some of you already know what we are doing at Nova. So for the ones that don't know what we are doing, so Novadiscovery is a French medtech company based in Lyon. And what we are doing at Nova is, so the purpose is to optimize the design of clinical trials. And how we optimize it by using in silico mechanistic models in order to run and to simulate clinical trials. So the main objective is basically to beta test the efficacy of a drug before running real clinical trials. And to perform that, we develop computational models with one main objective is to access to an unlimited number of virtual patients and to test different types of designs by using different regimens, using different drugs, exploring, for example, the combination of treatments, and to use this approach as, for example, also to define or to identify inclusion or exclusion criteria for upcoming clinical trials. So we believe that this kind of approaches are compatible and can be used with traditional approach in the field. So basically preclinical in vitro experiments, and it will increase the chance of success for future clinical trials by reducing in one way the drug failure rate, but also accelerating the time to market. So if we go to next slide, we have how we simulate these clinical trials. Basically, what is our approach? So everything that we are developing at Nova is basically based on knowledge. So we are developing mechanistic models using as basic material the knowledge extract from literature, from scientific papers. And we developed our models based on 3 different pillars. The first one is the development of disease mechanistic models for a given disease of interest. We'll plug to this disease models one or several treatment models. So the objective of these treatment models is to have an activity on a mechanism of action implemented in the disease model itself. And then the third pillar is a virtual population. So a virtual population is composed of virtual patients, and the virtual patient is a vector of descriptors of the model. So basically values of parameters that will generate from the distributions that we identify in the real world, basically. And the combination of these 3 pillars help us in simulating clinical trials using basically the design of protocols and the simulation of different types of experiments. So this has the main advantage of being compatible with data poor environments, but also, and that's the purpose of today, to use a platform that we developed for more than 10 years now, the Jinkō platform, to have a white box approach. So using this platform, we can link the source of everything that we made at Nova, so the knowledge, to all the steps of development for computational models. So it makes everything full auditable and trustable. We created also this platform to make it easy to use for non-modelers. So typically people working in, for example, the clinical development groups in companies. And also we develop this platform as a collaboration platform where everybody can work in a given subject with no focus on the expertise. So I think this is something very valuable. So for the presentation of today, the main objective was to have a focus on a Jinkō knowledge, so the knowledge management module of the platform. And I leave the floor to Tanguy, that is product owner on Jinkō knowledge.
Yeah, thank you, Claudio, and hello, everyone. So we'll be focusing indeed, as Claudio was just saying, on one of our key modules. So as we described before, indeed, Jinkō is really a full scope simulation platform, meaning that we can go from the formalization of scientific knowledge to running in silico trial. But today, yes, we're going to focus on this part here, the knowledge management. The knowledge management in a process for us, for example, at Nova, but when we work also with our sponsors or with academia, it's one of the first. It's the first step really when we have a research project, and then the goal of the knowledge module is to support user in creating a robust, transparent, accurate model. So this is what we call at Nova a knowledge model. So basically the formalization of knowledge from different scientific sources, with the ability for different stakeholders to discuss in the platform, review the data, the knowledge, and move on, then use that as a foundation. So free module, the knowledge, modeling, trial, analytics, and then transversally we have transversal feature. We put important aspect on the collaboration, commenting features, and also on connectivity to make sure that we can integrate into your ecosystem, making sure we can import data, import references, import articles into the platform, but also export your work, meaning that you can always take your work from the platform, export it in LaTeX, for instance, for documents in LaTeX, in Word as well, should you want to use it on another tool, or should you want to prepare for publication, for example, when you want to export in LaTeX. Just the last slide, and then we dive right into the demo. So this is a typical flow when working with Jinkō knowledge in the current state. So you will create a central repository of articles and references. The idea here is really to not have the knowledge from all your teams, internal and external, scattered in different places, but really in a central repository in Jinkō. Then from these sources, you can create extracts. We'll demonstrate that in a few moments to illustrate the concept of extracts. You can also evaluate these extracts. Then on the third step, then creating the documents that we're going to see, where your whole team and external experts can collaborate, ask for reviews, and then you have your model that you can use as a foundation. So in the context of Jinkō, you may or may not decide to move on to the in silico trial. In any case, the knowledge that you have can be used, that you have gathered can be used for real life trials or in silico trials. So let's get started. So what we did with Claudio is I'm going to go through kind of like the journey of what it is that typically using Jinkō when you work on your knowledge. So our starting point is Claudio here, my colleague for the research project. He's reviewing the documentation, he's working on the documentation, and he has tagged me on the specific aspect. So then I receive an email, and I can get access to the documentation and see where Claudio has tagged me. So here, what we see in the platform, so we're diving right into the documentation. We have here a team of researchers who are working in this particular context for the project we have created for you here. We put sample material on non-small cell lung cancer. So it's a area of research that very dear to Claudio. And here, the knowledge gathered is from different scientific sources, and the team is working on an LCLC and on the treatment, which is gefitinib here. And we're trying to observe the effect of different mutations on the efficacy of the treatment on the population of interest. So among those mutations, that's why here we have a specific interest in the KRAS mutation. And here in our example, Claudio has asked me to review a paper that he find of interest. And he could ask me, he could have asked any member of the team. So actually several members of the team could review the paper. So we have a look at that, so we can see. We'll give me the DOI here, so you know, use that here. Oops. And we have access to the paper because in open access here, we'll be able to download it. So I have this paper, and so I'm just gonna download it here on my computer, and then I can come back to the Jinkō platform. And I'm gonna add a source. So the source is very easy in Jinkō. I'm just simply gonna drag and drop it here. And what we see is like we automatically extract all the relevant metadata. So the DOI, title of the publication, date, the journal, of course, and the author. And I'm gonna add it to my folder of sources. What it does is that now that particular source has become available for me in the platform, for me, but also for all my teammates working on the project. And in the context of a review, the idea here is that each researcher can then pinpoint specific section of interest into the documentation and evaluate here. So you have two ways to do this. There's a very simple highlighting functionality. So the part that interests me here, because that's information that Claudio is looking for, is on the KRAS mutation. So I'm going to take this specific part that is talking about the command, the somatic mutation commands for NSCSC. And right here, I created my extract. This extract that is not created is not becoming available for my whole research team. Now, what I want to do, because now I've pinpointed this information, I also want to give an indication to my team, in particular to Claudio, because he's the one asking for the information, of how strong this piece of knowledge is. And to that, we have this special functionality in Jinkō, when it's a standard grid of evaluation, and you can assess how strong a piece of knowledge here. You can type it depending on its nature. Here is the statement, because of the piece of knowledge carrying scientific information. Could be an hypothesis, so a proposed explanation, or it could be data. Here I could say it's a statement with an excellent strength of evidence because it's universally accepted knowledge. Or here the idea is that we want to guide users in evaluating the strength of evidence. So we call it the strength of evidence. That's basically on two main factors, on correlations. So if the information has been correlated in other studies, or on the underlying quality of the method experimental design that led to this assertion, these statements. So it's a standardized way, because we do want to kind of have a scale, a common scale for all the researchers in the platform. But at the same time, it does leave flexibility to the appreciation of the researcher. Because in the end, it's really the researcher evaluating this particular knowledge that's going to decide, okay, here in this particular case, I know this journal, I might even know the author, I'm going to add some clarity to it. And then I can see in the article that it's a strong statement that has been supported in different research. The quality is what I would expect for this type of information. So I'm going to put this one as strong. Actually, I put it as excellent, because I like the authors. Yeah, other title. So that's one type of extract. The other thing I can do as well is here I have some data and also extract like this. So it's an other information that is relevant for Claudio. It's actually the distribution of KRAS in different subpopulations. The same, here is data. Indeed, so I just created 2 extracts that are now becoming available for my whole team. So now what happens is that I go back to my documents here. I'm now going to be able to answer Claudio with pinpointed information. So we created an investigation section here. So how does KRAS mutation affect the treatment response? Well, then we need to understand how important is the KRAS mutation, and that those 2 information I can now have for Claudio. The first one we create here, and then we have the table of data. And we can always go back from the document to the source. The traceability, transparency in Jinkō is very key. So it's true for the knowledge module. It's true for everything in Jinkō. Every time we create an item, we can see its link. And so here, if I click on the icon, then I can always open, and I will go back to the source, and I will see again the extract I just created in the context of this assertion. So here, Claudio is here with me on the same documentation. That's why I see him working at the same time as me. But what I would do if he's not here, we probably just tag him. Let's see here, or even here actually. Sorry. And Claudio is also able to go back to documentation and review the information. There. And then Claudio will be able also as well. If you wanted to, he could actually go back to my statement, he could change it as well. The click is excellent, and if Claudio does not agree with it, he could change it. He could change it, and we actually see in the history of the statement that it was updated after my initial creation. Of course, Claudio can also comment as well. And we first create discussion about the different pieces of knowledge that we gather in the platform. The idea is that at the end, we can review the model, the knowledge model like this. We can approve particular section of the model or not. So on each discussion, you have the ability to mark as completed to approve a particular discussion. It will always send into the archive. And here, so we created by those 2 steps. So it's really the core at the moment of the knowledge model into Jinkō. And then in the end, we give the complete documentation with very pinpointed, accurate information, visibility, details of the models here. We can extract that into context of modelization. We also can insert other type, any type of item created in Jinkō can actually be inserted into the documentation. And every time we link an item to documentation, we see the dependencies on this panel. Every references will be found at the end of the document. And now to go back a little bit to the interface. So in the end, what you have is your documentation, the whole list of your sources, the whole list of your extract. Your document itself can be exported into LaTeX, Word, or PDF. But you can also, at any time, export all your references in a BibTeX or in a RIS format from a folder, from an extract from sources. So the system is going to look for the traded information and go back to the references, and you can export that should you want to share that with colleagues. So okay, this is the references I've used to back my research. So a bit more on the interface, just going back a little bit. So you can see that you have the ability to here create group and projects into Jinkō. So just a small precision. But that means that if you ever want in the same group, you can create different projects with different users. So you don't have to share all your contents to all your users in your same organization. We can have targeted research projects. We can limit the number of people who can actually see what you're doing. Yeah.
We are also the administration. If you can see, yeah, you can navigate to the settings, the different settings.
Yeah, you have different settings here. I think that's more into the details. So you do have different way of managing the platform. Yeah, that's really the core of the knowledge part in Jinkō Knowledge. And in the end, you really have your repository here with all the sources that we have uploaded. Everybody has access to it. You can research your sources. The list of your extracts is also available. And then you have the documentation here that you can share with your whole team for review. And a little bit for the demo, actually. Maybe at this point, like, do you have any question on what we just demoed quickly here?
Yeah, I do. First of all, it's very nice, very cool that everything is kept organized and you have the possibility of exporting it afterwards, facilitating the writing process. But first question is this service free? I was just on your webpage and it says schedule a demo, but it doesn't say where I should go.
Yeah, so it's free for academia. So Jinkō Knowledge is part of an open science initiative, so it's free. From the website at the moment, you cannot get an access, but you can ask Claudio or myself, and we can create accounts for you anytime. We can even do that right now, actually.
Right. And the second question is how you deal with data. Is data private? What is the access of the company to the data you put in the platform?
So I can show that to you. So this is a few notes on the security of Jinkō. So there's two things. There's the first, the confidentiality aspect. Those two points. There's private groups. Us at Nova, it's only really the people who need to see your project. So for example, if you decide to work with Claudio's team on certain scientific aspects, then of course we will invite members of Claudio's. Sometimes also developers can access, but only for support purposes. If you really need, if there's an issue in the platform, like one of the developers has to access, but it's always a temporary access just for the bug fix. And then in general, we're in the process of becoming a partner with AWS, so a marketplace partner. And so for that, we do have a chart. Yeah, we have to respect high standards as part of the AWS Web Architect framework. We have a whole security team here. Of course, we work with the pharmaceutical industry, so data security for us is kind of key. And no, the security policy is always available on demand.
But you manage access. Who has access to your folder, to your working group? So basically, if I'm not invited to a project, I will not see what I will not even see this project, basically.
Yeah.
So yeah.
Yeah, exactly. Does that answer your question correctly?
Yeah, thank you.
You're welcome.
Is it possible to tag whether an observation is in vitro or in vivo or in what species it's in? It seems like when the annotator chooses the quality of the annotation, that they should also be able to say this is an observation in vitro, because that makes a huge difference. Same thing with the species.
Yes, this is clearly a good point. We are not splitting the information that way. For example, this information is more captured on the name or in the content of the assertion, not in the statement that we are doing. But this is typically something that if you have the need to flag it, basically it's something that you can suggest as a feature request or a feedback. And basically it's something that we can show directly in the platform. So when you are using the platform and if you identify some pain points, so particularly this one, if it is a pain point for you and it is something that you need to document when you are performing a literature review, it's something that you can suggest, and basically it will be considered by SSC team on Nova side, and maybe it will be part of a future release in that case. Yeah. So maybe it
Because
can be
fundamentally, that's much more important than the reader's interpretation of the validity of the information.
Yeah. Okay.
These, I mean, it's very subjective, and those points that are there. But what is critically important is this in vitro or is this in vivo? I mean, that's much more important than whether or not I think it's valid or not.
Okay.
Okay. So very good point.
Actually, we can create.
And then it would be great if that assertion was inherited for all subsequent assertions until the person, selects something else. That's a little trickier.
Yeah.
Yeah, perfect. So I'm gonna actually submit that right now. So it's gonna be in our backlog. So here I just put your notes, but you could also have recorded in the video screen. So at any point when you have access to the platform, you can definitely submit feedback. For us, it's good. We have a team dedicated to that, so we can improve the platform.
Each feedback will open a ticket basically on our side.
Oh yeah, it's already done. I just opened the ticket right now. Thank you.
You had a question?
Yeah, great presentation and the great software. Thank you for sharing that with us. So at what level, so how is this example document, how is that connected to a specific model?
Small question for
small question for me. So basically, we start by performing literature review. So we identify, for example, if we are working on an SCLC, non-small cell lung cancer, we will split the disease into several sub-mechanisms, for example, tumor growth, and each biomodeler at Nova, for example, will work on each submodel that we identify. So the first step is always to perform a literature review, extensive literature review, where we will identify the different biological phenomena that we need to develop. So for that, we typically will perform exactly the same workflow presented by Tanguy, but 1,000 times, for example. And then we identify all the biological phenomena that we will need to translate into mathematical equations using bioreactions, using kinetic reactions directly. So thanks. We have here an example. So this part for now is not directly done or performed in the platform. It will be a feature implemented next year. For now, we are doing it outside. But the advantage of doing the literature review right now is for each assertion we are creating, we have a direct link. And this direct link is documented directly in the model. So then we have a link between the knowledge and then an equation between knowledge and a parameter, between knowledge and the parameter value. And all these links will continue with the process of modeling. So when we have the equations, we'll start having a complete model, and then you will calibrate your model. So you identify some values of parameters, and then you'll validate your model. And once your model is validated, you'll use it to simulations to simulate a clinical trial, for example, and to answer questions. And the trick between everything we are doing is at the end, when we observe a given result for a simulation, and particularly if the result is not expected, what happens quite every time in research, we can go back to the piece of knowledge that lead us to produce this part of the model, and that lead us to obtain this result. And then we can make a link between a simulation output and the extract in a paper from what we developed or from what we test a given hypothesis. But what I am describing lead to two entry points in the platform. The first one is what we presented today, so the Jinkō knowledge part. And the second one is a QSP modeler, for example, that uploads an SBML file in the platform, and then the model can be used as it is directly in the platform, and we can use it to run a simulation. And what is missing for now, but will be produced during next month, is to be able to use this knowledge and then directly create in an interface, in proposed interface, in Jinkō, your computational model.
Okay, thank you. And so to build on that, what kind of, you mentioned SBML, what kind of mathematical formalisms do you support?
For now, systems of ODEs only.
Okay.
But we are planning to include also other types of models. But when we are building a platform, and a platform that need to be used for most people, we need to make some choices. So we made the choice of ODEs for now. And we are thinking of integrating other types of models like agent-based or DDE models. And having PDEs is also something that is quite required by community.
Okay, thank you.
Okay.
I guess I had a question following up. I mean, one of the things that this is very impressive for is connecting the literature to a text document where you have connection. And do you have I was just on one of our subgroups. They use NetLogo, not only because they can run simulations, but simply because it also has a formal structure for providing qualitative assertions, providing knowledge statements. So you could say cell type X has the following states. You could say transitions happen between this, this, and this. You don't have to make an executable model, but it has a syntax and a grammar for making essentially what I would call, I think you call it knowledge, but I would call conceptual model assertions. You can formalize the things that you're seeing here in the literature as a set of formal knowledge statements, expert statements. Do you have a language that you can use? You've got an observation, EGFR does something. Do you have a full way of formalizing that as an assertion in your platform at the moment?
Yeah, so at the moment, so the idea towards the creation of assertion. So as part of the roadmap for 2023, so we making the assertion evolve. So our founder, Jean-Pierre, is very precise on this point, and you're right, an assertion is really a phenomena, a verb, and then a result. And so we try, so currently when we do an assertion, an extract in essence could be an assertion. We have the formulation, and the formulation should really have this verb to describe like the dynamic relationship between two elements. So what we try to do is like in the evolution of the system here, that we help user write the assertion in a way that is really this dynamic. So
But you could, as I say, you could use something like the NetLogo syntax, which has a formal structure, that would allow, I mean, you can write any text you want, but it
Mhm.
gives a formal structure for organizing assertions that can then be operated on. Just the way SPML, you don't have to write ODEs with SPML. You can write any network architecture with SPML, or any compartment architecture with SPML, or a layout with SPML.
That's
And
true.
so I just wondered, so at the moment you haven't picked a language for formalizing assertions, because that's still something you're working.
Yes. Yes.
That's, I'm not a net logo person myself, but I was watching the subgroup working with it, and was very impressed with how powerful it was for taking qualitative concepts. FGF upregulates cell division. So cell has property of division, and then you have formal connections, which you can then reason on. So that to me was seeing that syntax was quite interesting. Yeah, I don't want to interrupt you. Jim has another question, and we should let you go back to your demonstration, because I think everyone.
I was just taking a note of not written. I was taking a note of what you were saying. Sorry, but not moving on.
No.
Just a quick question. So when you import a PDF, can you, I mean, often in a paper, there's a statement made that you want to capture, but it's not their statement, it's cited. So they say, macrophage proliferate response to IL-6, citation 42. Can you go down to in the PDF to the citation list? And is there any help with now pulling in that reference into Jinkō?
The specific references that I cited into a PDF, not at the moment directly from the PDF.
Okay. But yeah, I mean, just copy and paste, go to PubMed or whatever, but okay.
Yeah, there's also, we'll be able to import directly BibTeX file as well. So if you have those list of references or citation into a BibTeX file, so we can import that directly as well.
Okay. Or is there a way to import from like a PMID or a DOI?
A DOI, yes. PMID, yes, I think so. Yeah.
Okay.
But at the moment, so DOI, yes. The short
PMID,
ID,
not yet. Yeah.
But we just worked on that this week actually, so I think it's coming. The short ID, right? Yeah, I think it's okay. Yeah, so the DOI definitely, PMID, yes, will be coming. They will be coming.
Just looking if you have message or questions. Nope. Species, yes, I already answered that.
Yeah, this one too. Okay.
Are you guys interested in seeing some features? Maybe, I don't know.
Yes, that would be great. I think there's certainly, I'm sure there'll be more questions, but I think everything you show is interesting.
Okay. Maybe there is also something that we can, I don't know, schedule or maybe next time. So we presented today Jinkō knowledge. I think next step basically is to present you if you are interested in Jinkō trials and simulation. So we can use, for example, the NSLC exam and perform some trial simulations and give you an idea of what kind of results you can obtain from it, what are basically the workflow to run a in silico clinical trial.
That
I
would be
think that
great.
would be very interesting to have you back. I mean, there are a lot of people who use SPML related tools here. Tom has his own platform. We use antimony to generate SPML models. So many people here on the modeling side are used to SPML. One of the issues with SPML is annotation. And so having ways that you could do annotation of SPML models is something that's very exciting. So yes, I think all of these things, all three of your pillars, the model specification, the knowledge specification, and the trial design are all of interest to us. Yes.
Yeah. How about January 5th or February 16th?
But yes, let's maybe schedule a next meeting with a presentation of the rest of the platform or the modeling itself.
Definitely.
If you guys are interested, we'll be happy to present you.
Yeah, absolutely. We can send some dates, although those 2 dates are available at the moment. So that would be great.
Okay.
Yes, you thought he was joking. He wasn't joking. He really was asking for dates.
Yeah, it'd be great actually.
Yeah.
We can do it. 15 or 16 is fine.
Yeah.
We can even create accounts. By the way, we can create
Yeah,
accounts.
if you guys, some of you are interested, just maybe contact us, or I don't know if you, James, can centralize emails for guys that are interested. We just need names and emails, and we can create accounts.
Yeah.
Lorenzo, can you handle that? Lorenzo's the keeper of the email list. That's why.
Sure, I can do that. No problem.
I would certainly like an account. I know Joel would like an account. I'm sure Giuliano would. So probably others as well.
Same for me. Yeah.
Okay.
All right. It will be our pleasure. Perfect.
But please go ahead and show us. We'll keep. We definitely want to see more.
Okay, cool. I think we have one slide maybe with the next steps. If you have 5 minutes left, maybe to.
Yeah, we're just a slide on the where we're going with the roadmap with Jinkō knowledge. So what we saw today is the current step, the collaborative review documentation. So we have regular, for the roadmap, we have regular interaction with different stakeholders. So with the external users, so it could be, for example, you, if you want to be, if you're interested in participating in user research session. And from those sessions that we try to get a sense of where we should go to keep the interest of our users. And so we know that, for example, in 2023, one of the key priorities is really keep working this concept of extract assertion. So we saw today a system of tagging assertion extracts. What we want to add to that is new type. So for example, the in vivo command that was made could be a new tag. We want to have an history for each assertion, and we want to facilitate the creation of assertion between different pieces of knowledge from different sources. So right now it's from the same source, but we want to be able to say, okay, I have this particular extract from this source, from this reference, from this article, then another article, and want to be able to match them. And because it's a collaborative platform, so the use case we illustrated today when I put a strength of evidence as excellent, and then Claudio reviewed it and said, well, it's more strong. We want to keep a track of that, because it's important as well when we audit a model to see how we came to our conclusions. Then 2 other big aspects of where we're going in 2023. So keep empowering the collaborative creation of knowledge. It means that our users are putting a lot of articles in the platform. So for example, internally, when our own teams are using it, it's like, I don't know how many sources we put, but like a lot, like 100 sources or more. And so we have all this textual data that is on projects, and we want to use an LP to isolate and find biological entities and try to find correlation between the biological entities. And this way we can help our user find in the project, let them create assertion by saying, okay, those articles are talking about the same biological entities, for example. And then use those biological entities as well to tell our users that by connecting to external database, such as Crossref, for example, there are some papers talking about those specific entities, and you should be looking into it because it seems to be in your interest. So that's one big thing. We also want to have a more visual version of the knowledge model, so a graph that could summarize the different relationship between the different entities. So that's one of the aspects. And the other aspect is really easing scientific publication. So we already have, it's coming in a few days, the export to LaTeX. We want to go a bit further in easing scientific publication by targeting specific publication use cases. So for example, pre-formatting maybe the format of the export. So we will correspond to a particular journal, for example, Nature. And there's some other type of features that I want to look into, that, for example, plagiarism checker. Try to identify predatory journals when we select sources. A suggestion mode directly into the platform. So it's all those that will really target academia and the use case of publishing an article.
Yeah.
So that's very macro roadmap, but that's the macro direction. And then behind that, there's of course a lot of macro feature.
And yes, it's basically if Jinkō knowledge is facilitating the work of literature review, it's definitely a tool that we want to use to ease scientific publications drafting, because most of the work is already done when we are already keeping all these articles in the same place and having or sharing some extracts. So yeah, we believe that it's changing the way we are working inside groups, because we are not sharing a paper with some parts highlighted by email. Right now, what we are exchanging is extracts with some levels of confidence that we can have. We can discuss these levels within a group. So I think it's something quite powerful. And yeah.
Are there other questions? I have one, and I suppose the answer will be that it has not yet, but it could be done. And maybe it's more on the model building or the clinical trial side rather than the data, the knowledge side, which is one of the issues that we always are talking about, is the ability to annotate, especially in models, to some kind of reference ontology. So we keep dreaming that you'd be able to right-click on, say, the name of a variable, open up bioportals or the European equivalent for the European biontologies, and then say that this species is oboe entry such and such, representing chemical such and such. And it seems that from the way your software is structured, that it would be quite easy to do that. I don't know if you already have the ability to actually annotate a name with a formal ontological tag from one of the reference ontologies. If that already exists, it's fantastic. If it doesn't exist, it's certainly work to do it, but it shouldn't be, given the way your models, your interface is structured, I don't think it would be that hard to have.
Mm-hmm. Yeah. I think it's one of the main reasons why we want to integrate NLP directly in the platform. Because if we have to do it manually, it will take some time, because we are already doing the statements manually. We are annotating the extracts manually, and I think we want to keep it manually because we build on the expertise of biomodelers to do that. And I think if they are creating the models, they are the best persons to identify the strengths of an assertion. But for identification of biological entities, and particularly in this case, I think NLP can be really powerful to do that, making the link directly with databases like like EMBL, like such shared in the field databases. Yeah.
Because this is a problem that the same name is used differently in different papers.
Yeah.
And so Jim had to drop off because he had another meeting, but he would be the one to talk about how the same term is used inconsistently and therefore how important it is to connect to some reference ontology. That may be something you don't show. It's sort of hidden. It hides as a decorator that's normally not visible, but at least the term is tagged in a way that gives it an unambiguous meaning.
Yeah. Very good point. Yeah, thank you.
Other comments and questions? Joel, you're building a lot of models of this kind. Is this something that you see could be useful in terms of trying to analyze the structures that you face? Or Giuliano, you do the same thing?
Yeah, the organizational part of the things is very interesting. Yeah, it's very helpful, and the collaborative aspect of it too, right? Having other people, because we know that papers usually are not written by one person, so it's good to see that multiple people can also contribute.
Yep, this would definitely be some lubrication on the gears of research.
I mean, I guess at some level, this is something that would be even more valuable in a corporate setting, because typically when you're doing academic research, the teams are fairly small. And so it would still be extremely valuable for collaboration with 3 people. But if you had 30 people or 40 people doing a big drug discovery project, I could see it's not just useful, but essential.